Let's do a utility maximization problem with this utility function. So we want to maximize utility. We're going to assume that income is $12, the price of good X is $1, and the price of good Y is $1. Our budget constraint then is given by the following, where the coefficients on the X and Y variable represent the prices. One thing to note is that we always must buy good Y. If Y equals 0, utility will be 0. Okay, so if Y is 0 over here, the minimum then of these two values will be 0 and utility will be 0. So we must always buy good Y given this utility function. We don't necessarily have to buy good X, however. If X equals 0, this consumer still can get positive level of utility. Let's concentrate on this 2X plus Y. We're going to buy both goods if the marginal utility per dollar of good X is greater than the marginal utility per dollar of good Y. So for good X, the marginal utility is going to be the coefficient on the X variable, 2, and we're going to divide it by the price of 1. So the marginal utility per dollar for good X is 2. And for good Y, the marginal utility is going to be the coefficient on the Y variable here, which is 1. And we're going to divide it by the price, which is also 1. So the marginal utility divided by the price for good Y is 1. So here we have an indication that we're going to be buying both goods because the marginal utility per dollar of good X is greater than the marginal utility per dollar of good Y. So we're going to buy both goods, and if we're going to do that, we're going to take the 2X plus Y and now set it equal to the other part of the utility function, the 2Y part. And let's just simplify this, solving it for Y. So subtracting Y from both sides. Y equals 2X. And now taking our budget constraint, and where we have a Y, we're going to plug in 2X. Solving for X equals 4. And since Y equals 2X, Y will equal 8. Plugging those values into our utility function, we're going to have 2 times 4 plus 8, which is 16. And then on the other side of the comma here, we got 2 times 8, which is 16. So the minimum of 16 and 16 is 16. And that will be the consumer's maximum level of utility. You'll note here that utility will be lower at various combinations, such as X equals 5 and Y equals 7. That is on the budget constraint. That also would cost the consumer $12, but it would give a lower level of utility. Also, X equals 3 and Y equals 9. That is also on the budget constraint, but it too would give the consumer a lower level of utility. And also, X equals 12, and also X equals 0 and Y equals 12, another point on the budget constraint, would give the consumer a lower level of utility. Let's do another example. Same utility function, but this time let's change the prices a little bit here. Price of good X is now $10 instead of $1. Our budget constraint will change to this. And once again, let's concentrate on the 2X plus Y part from this utility function. And the marginal utility divided by the price. 2 divided by now the price of X, which is 10, gives us a marginal utility per dollar of just 1/5. And for good Y, the marginal utility divided by the price is 1, which is higher. So in this case, we're going to only buy good Y. How many units of good Y can we afford? The consumer has $12 of income. The price of good Y is $1. So Y equals 12. X equals 0. We're not buying any X here. And our utility will be the minimum of 12 or 24, which in this case is 12. You'll note here another bundle here, which includes both goods, X equals 1, Y equals 2. That is on the budget constraint. It exhausts the consumer's $12 of income, but the consumer would get a much lower level of utility, only 4 in this case. So we get a corner solution in this case, where you're only buying good Y. And in our last example, you're going to change the prices slightly. Here's our budget constraint at our new prices. Once again, we'll concentrate on the 2x plus y part. And for good x, the margin utility divided by the price is 1/2. For good y, the margin utility divided by the price also equals 1/2. So this is a special case. We could buy a combination of x and y or just spend all our income on y. We'll get the same level of utility. If we are going to buy a combination of x and y, we're going to do what we did before. Set the 2x plus y equal to 2y. Solve for y, and then plug into our budget constraint. And in this case, x will equal 1.5, and y will equal 2 times that, or 3. And our utility will be 6 in this case. The minimum of 6 and 6. On the other hand, if we only buy good y, how many units of good y can we afford? Our income divided by the price of good y, which is now $2. We could buy 6 units y, 0 units of x, and our utility would still be the same. The minimum of 6 and 12 is 6. Okay, that's it.